Hey YouTube, welcome back. Today we are talking about normalization, a core principle in relational databases that helps keep data clean, consistent, and easy to maintain. First, what is normalization? Normalization is the process of organizing data to minimize redundancy and avoid data anomalies. In simpler terms, normalization means structuring your tables and the relationships to reduce duplicate information, making your data easier to manage and update. The end goal: fewer errors, better performance, and more stable database. Okay, but let's me. But why this is important, or why normalization? So without normalization, you can run into data anomalies like insertion anomalies, like you can't add a new record without adding unrelated data. You can have like a deletion anomalies, like removing a record you don't need might also remove important related data. Like, yeah, so normalization helps you basically avoid these pitfalls by decomposing a big table into smaller related tables. How does this look like? It will look like something like that. So if you see this, we have in this table we have two sectors here. If you can see it. So in normalization, every column holds like atomic values, like, and there are no repeating groups or arrays. And instead of storing multiple phone numbers, for example, in one column, you would create a separate phone numbers table. So we have sector one and manager. So we have two tables, as you can see here. There is also second normal form of normalization, like it's must already be in the first normal one, and no bit trail dependencies on composite primary key. So if you have a table with a composite key like order ID, process ID, or manager ID, or sector ID, every non-key column should depend on the entire key, not just part of it. Third normal form must be in the second normal form as well, and no transitive dependencies. Non-key columns shouldn't depend on each other. Like if you have a customer age field that depends on customer DB, for example, you might place that logic in the application or calculated field rather than storing both of them. So by following this normal form, for example, you will create a design that organized and resistant to anomalies. Again, we have three things. We have first thing, every column holds atomic values, which is invisible, and there are no repeating groups or arrays at all. Number two, must already be in the first normal, in the first normal form, and no path trail dependencies and composite primary key. Number three, no transitive dependencies, like non-key columns shouldn't depend on each other. Okay, what is the pros and cons of normalization? The pros, the first thing, I guess it's pretty obvious, it's data integrity. Because we reduce duplicates and inconsistencies. Number two, we have easier update changes. Like changes in one place a property correctly, it's pretty easy. And number three is clear structure, like tables focus on one subject or entity. But what is the problems? What are the cons of normalization? First, we have a performance trade-offs, because highly normalized databases may require more joins, which can slow down queries if not indexed well. Also, we have complex query, like splitting data into many tables can complete queries and reporting. Okay, look at this example again. We have here employees. So and when we put it in two tables here, like we have sector, we have manager. When you're trying to make any query, we will have to do a lot of joins here. By using normalization, our data looks way more cleaner. So we take the manager table and we take the sector table from the employee table, and we just reference to them. As you can see that we have ID here, sector ID and manager ID, we references to them, and this is what we call normalization. But the problem that if we wanna get all the employee that has that first that for example, that have the sector name of them is the administration. So we have to make join. If we want to get all the employee that have the sector name of administration, and as well the manager should be in the east. So there is two joins, and in big databases, this will not end well for us. It will be the query will be way more complex. In practice, maybe many database designs aim for third normal form of normalization. I will create videos about what is the third normal form, what is the second normal form, what is the first normal form. Then denormalize certain parts if query performance suffered. We can talk about what is denormalization as well in the future. Um, we can also talk, yeah, that's it for this video. So in conclusion, let's wrap it up. um that's the basic of normalization in relational database. By structuring your tables thoughtfully, you can eliminate redundancy, prevent anomalies, and maintain clean data. If you found this video helpful, like it, subscribe, and drop the comment in the notification section below so you won't miss any video. And yeah, that's it for you guys.